Okay, so it's 8 right? So we should start with services today. There is one more topic that we are supposed to cover. Okay, let's do it. No problem. Uh, so we saw that an IP address of class A is of, you can say, network host. So if I want less networks and more host, then I can use this type of range, right? So if I say I want only 10.1.1.1, here this address is having less number of networks, 2 to the power of 8 networks. You can say I have these many numbers for network part, and hosts are many. If I want lesser number of networks, I can go for class B range, network.network.host.host. So I have 2 octets reserved for the network part and 2 octets reserved for the host part. So again, if I have a medium size enterprise or corporation, I can say I have 65,000 addresses. Okay, I can go for B. And if I say I have a small company, or it is my home purpose, I can use class C. That is the reason we always see 192.168 or something. But the issue that we saw here was, if I want more than 256 numbers, I have a choice to go for 65,000 numbers. But what is the give and take between? I don't want this many numbers. Or let's take a small example, not going in the higher range. Let's say I want less than, I say I want only 100 numbers, or let's say I want only 10 people in one network. If I want 10 people, again 256 network is not good, right? So we want to be more specific. These networks that we saw is a class A, class B, class C network. I don't want to use this feature. I want to use something that I require. I want to use only 10 IP addresses in one network, right? So how can we do that? Now, anytime you see 255.255.255.0, this is the subnet mask of class C, right? So how do we write it in binary? You can say 1111, all zeros. This is how we write, right? So now, if you want to calculate the number of hosts, you can calculate from here. So I say 2 raised to the power of 1 will give me 2, 4, 8, 16, 32, 64, sorry, 32, 64, 128, like this. So if I take 8 bits, I will get 256 IP addresses. If you want lesser number, you can go from here. Keep these bits on for, or keep these bits off for, and turn these bits on. Let us see what will happen if I say like this, 1111. Let us say we borrow 1 bit from the network, from the host part, and I say these bits are free. These bits are for my host, you can say. So what I did here was I took out 1 bit. How will you write this in decimal? 255.255 dot. This first bit has a value of how much? On this 1 bit, first bit has 128 above it, right? I'll show you. Wait just a moment. If you have 8 bits, every bit has a value of 128. Second bit has a value of 64. Third bit 32. Fourth bit 16, and then same nibble 8, 4, 2, and 1. So anytime I write 0 below this number, it is, if I say this is 1, means the value, and all zeros means it is 128, right? Correct? Definitely. So if I borrow, if I do like this, if I say I take 1 bit from the, sorry, if I say I borrowed 1 bit from the network part, how will this become now? This part is also network, and this becomes my network part. How will I write this like this? But what will happen? Now you borrowed 2 bits from the host part. So this becomes network. So how many sub networks will you get? Now if I say my network range is 192.168.1.0. But after doing this, how many bits are these? 25 bits, because 8, 16, 24, right? I am using the 25th bit. I can also write it like this, /25. This is known as the slash notation. So if now the question will be like this, for example, they will say, okay, There is an address with this slash notation. Which network does this address belong? As of now, if I say I have this subnet mask with this IP, what will be the breaking point? How many sub networks will I get? So how many sub networks? I borrowed 1 bit, means I get 2 sub networks, because 2 raised to the power of 1 is 2. So my networks will be divided into 2 parts. 128. These 2 numbers are now network IDs, and I cannot use these 2 numbers. What will see? So I broke the network into 2 parts. This is the first network, this is the second network, and what will be the, so every network requires a broadcast also, right? So what will be the broadcast of this network? Here it will be -1, means 1.127, and here it will be 192.168.1. Last number, you can say. So anything between this, any number between this is a valid IP address. Now I broke the network into 2 parts. Between here I will have 192.168.1.1 going towards 126. All these numbers are called my valid IP addresses. Now what we will do is, we will do a small exercise. Let us see in reality is it happening. Let us see if I take 2 PCs and a switch. Let me assign normal addresses 192.168.1.1. So this becomes my network 192.168.1, and this is the first address from it, right? Okay.
Yeah.
I'll go on the others. Okay. Same I will give here 192.168.1.2 I'll say. Now I am not doing anything related to subnetting. I am just doing normal numbers. For example, I will give the first number and I'll say 200 to it. No problem. Will they communicate? They should be able to communicate. Why? Because they are a part of same network, right? This number is not different, right?
Yeah.
Let us see. Can we ping it? Yeah, reply comes, means we both are a part of same network. Right? Now we have seen that this, if I change the subnet mask to this, if I change my subnet mask and I write this in the last octet, what will happen is the device will do the binary ANDing, and he will say, okay, he will calculate like this, you can say, and he will make out, oh, I have 2 networks and this PC belongs to which network. Let us see. I will only change the subnet mask. Let us see the effect of it. I'll go in here, IP address configuration, and I will say 128 over here. Please give me a moment. Yeah. Okay. Now, okay, are you there, sir? Mr. Rice? No. Yeah, there was someone I need to talk to him. Okay. So now I change the subnet mask over here, and over here, I will also change the subnet mask over here. Right? Let us see. Earlier they were pinging. Now can they ping? No. Why? Because they both are a part of separate network. Now seeing this diagram in the back end, your device did the binary. He said, okay, this is the first network, this is the second network. You want to go to someone outside your network, you should be giving me a default gateway.
Yeah.
So there is no default gateway. How will he come? Now technically this device will not even bother to generate a ping. I will show you one day, but this is how subnetting works. So the question will be like this. For example, if I take a test, I'll say 192.168.1.99/25. Which network does this IP address belong? So if I say /25, okay, so you have to first write the subnet mask. So 25 means first 24 bits are fixed. Okay, 25 means I'll turn on the first bit. What is the value of the last standing bit? It is 128. Always understand one thing: the last standing bit is having the value of 128. This will be your block size. What is this? This one is your block size. So the network will be divided into two pieces. But what is the start? What is the cutting range? The cutting range is 128.
Now
Getting?
slash 26 means
Yes, yes. I'll tell you /26. Let us discuss /26. Now, if I give you a number like this, 192.168.1.0/26, what is the subnet mask? 128 plus 64, right? So it is 192. The subnet mask becomes 192, right? So let us write this in binary. Let's see. 11111111 like this. Okay. So these are 2 bits that I have turned on, right? So what is the value about this bit? It is 64, isn't it? 128, 64. So the last standing bit will give us the block size. Okay, so let us see. How many networks will I get? 2 raised to the power of 2. I will get 4 subnetworks. 1, 2, 3, 4. I get 4 subnetworks. What is the block size? If you say 64, okay. So my network will start from 0. Next network will start with 64. The third network will be plus 64. So the third network will be 128 and fourth network will be 192. 0 plus 64 plus 64. And where are these numbers? These numbers are in the last octet. This last octet is my interesting octet, right? So this is where the changes will occur. Now let us see what is the parinam of this. Let's see. 192.168.1.0 is my first network. 192.168.1.64 is my network ID. 192.168.1.128 is the network ID, and fourth is 192.168.1.192. I get 4 subnetworks, and in every network I will have a broadcast ID, right? So what is the broadcast? 192.168.1.63 becomes my broadcast ID for this network segment. This is again one subnetwork, same as this, and this is same, right? Sorry. This piece is same, like this. So here I can write, I can say 63. So I cannot use 0 and 63, although the numbers 192.168.1.1, are my valid IP addresses towards 62. So if I say I have a number 192.168.1.111/26, which network does this IP address belong?
26.
Yeah. So see, the answer is in front of you. Then the number is just, don't see the number. Just see /26. Okay, /26 means 2 bits. What is the block size? What is the last 26 bits value? 64. So 0, 64, 128. Okay. So this number comes between 64 and 128. So the network IP will be, so this belongs to this network, you can say. Getting the point?
Now one more time.
See, I give you one number. For example, I give you one number. Let us do it again, no problem. I give you one number 192.168.1.77. I say this is a /26. Which network does this IP belong? So let us calculate. Okay, if you say /26, okay, let us see the subnet mask. 8, 16, 24 are gone. 26 means 2 bits. So the 128 plus 64 values. So 128
190.
plus 64, we write 192. We got the subnet mask, right? So last standing bit was 64, right?
Last standing bit 64. Okay.
128 plus 64 we did, right? 2 bits are on. 25th and 26th bit is on.
Yeah.
Rest are zeros. So I say, okay, no problem. 64 is my block size. So, okay, the networks will be 192.168.1.0. Second network 192.168.1.64. Third network plus 64, 192.168.1.128. And I will have one more network 192.168.1.192. You can say I get 4 subnetworks if I use this slash notation. This is the subnet mask. And if you say an IP address of 77, where does it fit between them, right?
Yeah, between them. Yes.
So this is the subnet. This is the network of this. So this IP address belongs to 192.168.1.64 network. Let's do this example. Let's go in here. First PC, we will have 192.168.1.1, but in here I will say 192, right? And I will say over here, let's see how many networks we have. 1.0. Let's build it here. We'll take a small example. This is 1.0 and this is 1.64. 2 networks. There are totally 4. I can use any 2. So 63 here. And so first I will assign an IP of 1.1 and 1.60. I'll say. Will they communicate? Mr. Reis?
Yeah.
If I say I assign 2 PCs with addresses from this network, will they communicate?
Which one? 63.
One address is 1 and the second address is 60. Are they both in the same network?
Yeah, of
They
course.
will communicate, right? So let's go in here and say 1.1, but always see the slash notation. And in here I will say 1.60, for example, and here I'll say 192. Now can I ping 1.1? Yes. Why? Because these both are a part of same network segment, right? Now what we will do here is,
Different network, we have to assign gateway, right?
yeah, so I will assign the other PC with an IP of 65.
Okay.
Let's see, are they this PC? I will say 65. By mistake, some admin came in and he gave the address. Now the communication will not happen. 2 minutes before it was happening, 2 minutes later it's not. So we have to check, okay, what is my IP address? What is my subnet mask? That is the reason we do IP config always. We sit on the device, we say IP config, okay, what is my IP? Oh, 65, 192 means the block size is 16. Oh, you are going outside your network. So you say you are 65 and he is 1.1. You will not be able to go to him if you are using a switch. You require a router for that. Okay, getting the point, sir? Okay, let us see one example. Let us say I have a number. Now, understand one thing. This thing that we are using is called classless. This does not belong to class A, B, C now. Because what you can do is you can say 10.0.0.0 and a /26. Same thing will be there, because here the interesting octet becomes this. The subnet mask becomes 255.255.255.192. So here I am reserving these 4 octets for the network part. So that is the reason we see in companies also, they use 10.subnet, but they do subnetting. Okay. Okay, let's see one example. Let's say 192.168.1.0/27.
Okay.
Now tell me the subnet mask of this. Try to calculate. If you have a calculator, you can calculate. If you want to write it here, I can give you the power command to the window. Or you can do it on a book and tell it to me, no problem. Because this is the only place wherein we have to do the writing stuff. Or later on, we can do all the commands and write it on the notepad, no problem.
192, 255, 255, 255, 224.
Yes, 224, correct, exactly. And what is the block size?
3. 3.
Last standing bit?
Last submitting is 3.
3, right? What is the value above that?
2 raised to
2 raised to 3 will tell you how many subnetworks you will get.
yeah.
So you can say I get 8 subnetworks, 2, 4, 8. And what is the block size of each subnet?
Sorry?
What is the block size of each
Block
subnet?
size. Okay, and this
32 is the block size, right? Last standing bit is 32,
yeah.
right? So your block size will be 32. So network will be cut in 32, 32, 32. So I will start with 0.
How it becomes 4?
What?
Because 4 bit is on or what? This,
No. It is 27, right? So
Yeah, 20.
you have 25th bit, 26th bit, 27th bit, right?
Yeah.
Rest are off.
Yeah.
So here it is 16, here it is 32. So the last standing bit is 32, isn't it?
Yeah.
So I know that, okay, 32 means my network will cut after 32. Plus
Yeah.
32, 64, plus 32, 96, so on and so forth. So if you calculate more, 96, then 128, then 160, then 192, then
How
2.
become 96 plus 32?
Plus 32, plus everything is plus 32. So 0 plus 32, okay. 32 plus 32, 64. 64 plus 32, 96. 96, 32. Sorry, I missed some number, it seems. No, it's correct. 128. 128 plus 32, 160. Plus 32, plus 32. Last number will be 255. That is your broadcast. So how many numbers do I get? 8, right? 1, 2, 3, 4, 5, 6, 7, 8. 2 raised to the power of 3. There are 8 subnetworks over here.
You mean like this box 8, right? 2 raised
Yes,
to 3,
8
right?
boxes like this. Yes, correct. So in here, I have, this is my small subnetwork, and this starts from 1 and goes to 2, 3 till 30.
Great, yeah.
So if I have two devices with this slash notation, they will communicate from 1 to 30, and like this you will have the breakups of your network. You can see that. Let's test it. Let's say an address from this. Let's say one address is 1 and the second address is 30. Let's try doing that. 224. Second PC I will give 30, and I'll change the subnet mask to 224. They should ping. Yes, because they are logically in the same network. Right? Now the other device, I will say 35, for example. Let us go over here. 35. So the device calculates, he says, okay, 35 and 224. Oh, 224 means 32. Oh, the block size is 0. So next network is 32. Do you want to go to whom? You want to go to 1.1. Oh, he is not a part of my network. Let it be then. I will not generate a ping. I don't have a default gateway. See, it will not communicate.
Yeah.
If again I go and say you are, if I change that guy, if I change the other person to 36, for example.
Same network.
Yeah, same, they become same network, right? Then he can communicate. Because he knows, okay, 35, 36, same network. Yes. The trick is sometimes people will give us like this. They will say, okay, there are 4 or 5 PCs and one PC has an address of this and one PC has an address of that. So will they communicate? But what they are seeing is this is a broadcast IP, and we will not be able to communicate using we cannot assign a broadcast IP. So you can say, oh, this is not a valid IP address. This is a broadcast address, and a broadcast address cannot be assigned to end hosts.
Okay.
like that.
First and last.
First and last, yeah, network. That is why we minus 2 out of every network. Clear? Let us see. 192.168.1.0/28 means I'm using 4 bits. So what should be the subnet mask? 8, 16, 24 gone. 4 bits we are using.
232.
See, the total
42,
values, yes, total value is 255,
Yeah.
and a nibble has a maximum value of 15, right?
Okay. 1248.
A 15 value. So if I say 255 minus 15, what number will I get? 255 minus 240, oh, 15. I gave you the answer by mistake. See, you can calculate it in 2 ways. You can add 128 plus 64 plus 32 plus 16, or you can simply subtract the total number from a nibble. A nibble is maximum 15, right?
Okay. Okay.
So 255 minus 15 is 240 you can do. But I'll give you all the notations today so that you can understand, okay, the values are same in here, in here, in here. So I get the subnet mask of 240, and the last standing bit is value. What is the value of this last standing bit?
8.
16.
16. Yeah.
16, right? So the block size will be
2 raised to 4, right? 2 raised to 4.
yes, you can say that. Or else you have a block size means what is the cutting edge of every network.
Okay.
So where will a network start and where will a network end? So one network starts with 0, another starts with 16,
Another start.
with 24. Oh, sorry, 32 plus 16 plus 16 plus 16.
Yeah.
48,
48.
64. If you know the table of 16, this is the table of 16 clearly. So I will have 15 as a broadcast in here, 31 as a broadcast in here, 47 as a broadcast in here. How many sub networks will I get? 2 raised to the power of 4. 2, 4, 8, 16. 16 sub networks you will get. Clear? Getting the point?
Yeah.
Let us test it. 1 and 14, and then we will say 17. This is 1.1, subnet mask of 240.
Yeah.
Other device 1 and 14 with the subnet mask of 240. Ping 1.1, pinging,
Yeah.
right? Let's go on the other side and let's say 17 to it. Sorry, 17. By mistake, if I say 16 over here, it will not accept. Why? Because it says 192.168.1.16 is a network ID. You cannot assign a network ID. Let's go and ping 1.1 again. Now the reply does not come up. Why? Because they are a part of separate network segment. Let us say, now try to calculate 192.168.1.0/29 by yourself. What will be the subnet mask?
Okay. 248.
Okay, good. 248, correct. And what is the block size?
Block size between 0, 8.
Yes, 8 is the block size. So you will just keep on adding 8.
Okay. 8, 16, 32 like this, right?
Yes, you can say that. 8, here 8 and 16 and 30, 24.
Oh, sorry.
No problem. This happens. Yes. But better than else. It's fast. Yes, you are understanding quickly. No problem. So here I have only 6 valid addresses, right?
50,
So
yeah.
if we had the question like earlier, I want only 10 IP addresses in one network. Is your network correct now? We said we do not want 255 addresses, but we want only 10 addresses. So we know, okay, I can suggest this, but this will have only 6 valid addresses. So we can suggest /28. This is a suggestion that we can say. We can say, okay, with the slash notation of /28, you get 16 IP addresses, 14 usable. So 10, if you want a network of 10 addresses, you can use a /28. I recommend you that. Clear?
Yeah.
Okay.
Let's see, 10 networks, it will not come in one block, right?
No, 10 IP addresses. In here, in this slash notation, 10 IP addresses do not fit. Because here the block is 28. So 10 people cannot sit on 6 chairs, right?
Okay, now I got.
Yes. So we say, okay, this is the thing that you can use.
Okay.
Okay. Now the last one is the industry's favorite 1.0/30. /30 has a subnet mask of 255.255.255.252. Let's see. I'll write the last octet 1 2 3 4 5 6 0 0. So what is the value about this bit? 1 2 and 4, isn't it?
Yeah.
So the block size becomes 4.
Okay.
0
yeah.
4
8.
Yeah, 8, and here is 3, and here is 7, right? So I get only 2 addresses. So if you have a point-to-point network, for example, you have 2 devices and you want to connect them in this fashion, like 2 routers. If you want to, you can and you should use /30 only. Why /30? Optimum utilization of resources, because with /30 we have only 2 usable addresses and we have 2 PCs.
Yeah.
So that is what we recommend. For point, and in your networks also you will see router to router connecting with /30 only. /31 will give us with 1 IP address only, and /31 does not give us many. /31 technically there are 3 addresses, but only 1 address is inside the network.
But /30 give 2 IP address, right?
Yes, see, 1 and 2, right? /30 is giving us 2 valid addresses. If I say /31, then
Okay.
it gives us 0, 1 and 2. Next network starts with 3. So only one person, he cannot have a network, right? We want at least 2 people to get married. So that is why we use /30 everywhere. /31 is of no use because only 1 IP address is what we get. And /32 you cannot use, but I will show you how to use /32. If there is only 1 person, you can use /32. I will show you using on routers. We will use that number. Okay. So getting the point.
Yeah.
Now let us see something interesting. Let's say I have a network of 172.16.0.0, right? This is /22. Now, up to this point, we have discussed 8, 16, 24. We have discussed above this value, right? Now we are going in the left-hand direction. 1, 1, 1, 1, 1. So give me a second. Now, if you notice in here, how many bits are there for the host part? I borrow. Now I say 22 means this side over here, right?
Yeah.
This is the host part, right? Every block you use, every block will have the same values, 1, 2, and 4. What is the last standing bit? 4, right?
4, yeah.
And this becomes your interesting octet.
Okay.
So the block size is 4. Your network will start with 0 and second network will start with 4, isn't it?
Yeah.
Where will I write this? I will write it in the third octet. I will have 172.16.0.0 and the second network starts with 172.16.4.0.
Okay.
the interesting octet changes in this one. Sorry, I think I deleted it. Getting the point? So what is the broadcast of this 172.16.3, isn't it? The last usable IP is 3.
Yes.
And here you will write 255. Why? Because you cannot use this octet 0. So what will be inside this one? I'll show you. Give me a moment. Here you will have addresses 172.16.0.255, last address, right?
Yeah.
The binary
Then
rule says
start 1 dot.
yes, 1.0. And then we say 172.16.1.255 last. But notice in here, all these addresses here, 2.0 and 2.255, 3.0. All I'll write it down. No worries. I'll just write it down.
This cannot use.
Give me a second. Huh? I'll just shift it here. In here, 172.16.2.0 will come. 172.16.2.255 will come, and 172.16.3.0 will come. All these addresses, give me a second. All these addresses are valid addresses. All these addresses are valid addresses. And if how many hosts will you get? 2 raised to the power of 10. 2 raised to the power of 8 is 256, right?
Yeah.
2 raised to the power of 9 is 512. 2 raised to the power of 10 is 1024. I will subtract 2, 1022. So if you have a requirement of more than 254 hosts, you can borrow your bits from any other octet. And what will be the effect of it? If you say now the block size is same in every octet. Here using /30 gave us a block size of 4, and here also using the third last bit, you can say, gave us a block size of 4. But in here, all these addresses are valid IP addresses.
Okay. Inside
Okay.
this. Okay.
You want to write this down?
Yeah, let me check. See this 172.16. How this /22, right?
Yes.
From this, how we expand this.
Okay. Let us do it again. Wait. Let us say I have a number 10.0.0.0 blank number. I said /22.
Okay.
Right. Let us find the subnet mask of this. So 8 is here. 16 is here. If I write this, it becomes 24. Means there is some changes in this one. Right. Third octet becomes our interesting octet.
Yeah.
Okay. So 22. Let us write it in binary. Let us say 1111. 16 bits. 22 means 22 bits are used. So 17, 18, 19, 20, 21, 22. And then I will say rest all are off. 23, 24. This is how I calculate first. Okay, I say this is the interesting octet. What is the value about this bit? 4.
4. Yeah. 4.
So my block size becomes 4. So my network will start from 0. Second network will start from 4. But I say 0.0 actually. Not 0. Because this cannot be anything, right? So 0.0 and 4.0. Right? So if I say the second last number will be 3, but 3.012, what is the last number in every octet? 3.255. Getting it?
Yeah.
Now, if I say this is my interesting octet, this one here is my interesting octet. The changes will happen in this octet. Let us see how to write the change. 10.0.0.0 and 10.0.3 255. This is our interesting octet. You're getting it?
Yeah.
Any address between it, this will be 10.0.0.1, 10.0.0.255, 10.0.1.0, 10.0.1.255, and 10.0.2.0, 10.0.2.255, sorry, 255, so on and so forth. 3.0 and 3.255, you can say. Getting the point?
Yeah, all these IPs are also valid.
Valid.
Right?
These all are valid IP addresses. Let us test this. Let us say 1.255 and 2.255. Okay?
Yeah.
Let's say 10.0.1.255 tab. What is the subnet mask? 255.252.0. Correct? Valid IP address. And let's go on the other side. 2.255 and let's say 255.252.0. Can I ping 110.0.1.255? Yes. So I can come to a conclusion that 2 raised to the power of 10, I have 10 bits reserved for the host part, isn't it?
Yeah.
You have 10 bits for the host part.
Yes.
So 2 raised to the power of 10 is 1024 and minus 2 network ID and broadcast ID. So if you have a network more than 1000, you can create a block of this.
Yeah.
Clear, getting the point? Okay.
Yeah. For the huge requirement, right?
For a huge requirement. Now, just taking a small example, don't worry about this. What if I keep these bits into the network part and keep all the other bits off? For example, if I say this is 0, block size will remain the same. Block size, but the interesting octet will be this one now. So now my network, if I want to write, it will be 10.0.0.0. The second will be 10.3.255.
Yeah.
2 raised to the power of 18, you can say. So many networks. Clear, getting the point?
Yeah.
Understanding subnetting? So if you understand, today I suggest you write all the slash, so I'll consider it as a homework, 192.168.1.0. And you have to write /25, /26, /27, /28, /29, /30. So what all topics we discussed today has all this stuff. Just make sure that you write it on a piece of paper so that it will automatically be a part of your. Okay. Any doubts regarding it?
No.
Okay.
Actually, one doubt is okay. Finally,
no, don't worry. You practice it today. Tomorrow, get me your doubts and we will solve. See, you can take any number. Take a number, any number that you want. 100, 177.232, 36, 47, or any number, and write a slash above it. And then say, tell me the block size. Tell me the network that it belongs. Now, anytime you get a number, do not see this. Do not see this. Why? Because this will frighten you away. Always see this part. /27. Okay, with /27, you can find out the subnet mask 255.255.224. Okay, so now I understand that these 3 bits, you can say, these 3 octets are reserved. They will be fixed. Half of the problem gone for us. Right? So we know that this is of no concern to us. So we know, okay, this is the interesting octet. Okay, let me see. So if you say 32, then block size is 0 and 32. Okay, the address that you gave me is 177.222 47.32. This is a network address because 32 is a network IP and this belongs to 32 network, and the valid IP will be 3334 like this. Just try the thing that I gave you. This one is very simple. The numbers will only be frightening, but never see the numbers. Tomorrow we will take some random numbers and we will see how to calculate. The trick is you should see the slash notation. Everything will be very easy. In the exams also, they show us some convoluted numbers, and seeing those numbers, I myself used to get frightened up. But once you see the slash notation, write the subnet mask, write the block size. In 1 minute, less than a minute, you will be, later on if you practice this, you just tell a number and immediately you will tell the network IP. Just see the last standing bit, the block size. In 1 minute, you will get, inshallah, you will be able to do it very fast. Okay, sir?
Okay.
Okay, let's meet on Monday. Tomorrow is Friday, right? We have an off. So
And
let's.
this one more.
Yes, please proceed.
And, this video I can download because